it's Tom from Inspiration Metalworks, and thank you for joining us for another weekly shop update. I want to say this is shop update number, what are we, 15, 16? I guess I better check before I publish this video, but we're getting up there, we're doing all right. In this week's video, we make a spanner wrench. Just kidding. Anyways, so we've got a spanner wrench to make, and the wrench itself is for the Colchester 13-inch Colchester lathe that I recently upgraded to. If you haven't seen anything on that, take a look at the previous videos. If I can figure out how to do this in YouTube, I'll put a link to those other videos up there. Otherwise, I'll put them in the shop description. Anyways, I've got this new to me, a 1966 edition of a Colchester 13-inch lathe right over there. And one thing it did not come with is the spanner wrench to change the chucks, spindle chucks. Now, I only have one chuck for it right now. It's the 3-jaw chuck that it came with. And when I got this thing up and running, I was so excited. I was like, okay, let's true up this arbor that I've got made, and let's get to work on some of the brake project that I've been doing. And I started working on it. My God, it was making things worse and worse. I think there's something wrong with this chuck. Either something simple, like they put the jaws in out of order, or something that's causing it to be really not concentric with the rest of the headstock. So it needs servicing, right? It's new to me, but it's been in production for years and years. It needs a good service. So I couldn't take it off to do that without the spanner wrench. Luckily for me, the Texas gun guy, Martin E. Mayer, you may know him. He's got his own YouTube channel. Check that out. And but he's got the newer model, the Mark II model of what I have. And so he was nice enough to send me some pictures. Let's take a look at those pictures now. And through the magic of the internet, we have some photographs that we could use to try and recreate this spanner wrench. Now, I didn't try and make it exactly the same. What I did do is make something similar. As you'll see later, I made a second version. So let's get started. Well, it appears that for whatever reason, yet again, whenever I try to record my screen, I'm not getting the audio. So rather than bore you with 10 minutes of drawing, I've sped it up to about 2 minutes worth, and I just wanted to talk a little bit about what we did. So I had all these photos from Martin, and it showed me the critical dimensions of the spanner wrench. And so I knew that the biggest critical dimension for me was the radius of the arc, and then the pin itself. So figuring that out. I wasn't really sure how I was going to do this drawing. I just kind of played a little bit. I went ahead. I knew that critical dimension was the one piece. The rest of it was really just playing around, and then the pin itself, right? So knowing that the dimension of the part that engages in the spindle lock was important as well. So I drew those as separate pieces, and then I welded them together in the drawing itself. And so you can see I was going through trying to figure out locations, trying to figure out angles and dimensions. I realized I didn't exactly like where some of it was lining up. I wanted to round things out. Kept making mistakes on where things were supposed to be. Realizing I put an arc in here and went, oh, wait a minute, nope, it's supposed to be at the pin, the other end of the pin. So took a couple of tries, but all in all, in less than 10 minutes, because I had the drawing or the photos to work from, I was able to put together a very basic spanner wrench. And so I'm quite pleased with it. I think it turned out pretty well, but I went through and cleaned up little things, chamfers, rounded edges, things of that nature. but the drawing went pretty quickly. And so thanks again, Martin, for providing the photos for me. Well, we've been doing a bit of cutting lately, and I've noticed that ever since we moved into the new shop, I've had a little bit more bevel on the cut than I'm comfortable with. You know, at first I thought maybe something got out of adjustment or things like that. I thought maybe my cutting heights were off because, you know, plasma does a teardrop when it cuts, and so that's why your height control is so important with a plasma cutter. That being said, I went back and I looked, and I think what's actually wrong is I think the torch itself is out of square. I think it just got, you know, pushed, and so it's tilted either forward, back, or left to right, somewhere in there, or maybe a combination of the two. And so I'm getting that off camber cut. So I'm going to do some quick checks on that, and we'll see what we have. I think today might be a good day to do some maintenance on the plasma. Now, first thing I need to do, let's get this thing cleaned up a little bit. It gets a little dusty from cutting. So tools today, just a simple square, just a 9/16 wrench to loosen, make adjustments, and a 1/8 hex Allen wrench. So first things first, let's raise this up. Raise as high as we'll go. And I'm going to get down low on this and see if I can visibly see an issue. And actually I do. I already see something. So I'm canted this way. I'm canted from left to right. So I can already see that. So I know I've got to make an adjustment there. Probably take the rule out of this and just use this. But see, I don't know if I can. Maybe I'll bring you in at a different angle. And we'll see if I can get this in on the camera so you can see what I'm looking at. Alright, so we're looking straight down the body of the torch. And so what I'm seeing from here, if we look at it, we're about, and I'm eyeballing, I don't know if it's showing up well on the camera, but I'm seeing, man, I'm shaky as heck today. I'm seeing quite a bit of difference between top and bottom. I mean, it's not a terrible amount, but it's definitely enough that would cause that bevel imbalance that I've been noticing. All right, so somebody's having fun today. Oh, I love this place. Anyways, so I think that's probably my big culprit. I am going to turn at a 90 degrees and see front to back as well. So let's check that. I'll see if I can get you in on camera for there too. So we're looking at it from from the side now. So we've gone 90 degrees, and actually it looks like I'm tilted this way a little bit. Looks like it's kicked out a little bit there too. So I think we've got quite a bit of updates to do here. This is where having a snap and cut or a pop away mount is so much better, right? Because it keeps everything nice and square for you. You can pull the whole thing off, pop it right back on, and it's always square to your work. I didn't realize this thing had gotten so far out of whack, but it is time to get this corrected, and maybe someday, I know I've talked to Keith Fenner about this already, but if I can get the funds saved up for the pop away, I'll probably do that this year. But alright, so there's our work for today. Okay, I made a mistake earlier. I called this 9/16, it's actually 7/16. Looking at it going, why does that not sound right? Well, that would be why. So the first thing that we want to do, we've got these set, the Allen set screws here are here actually just to keep this all square, right, and to provide the clamping force. And then we use the nut and bolt combinations to clamp to the bracket, and then this bracket can move up and down as well. So for our front to back, we'll move this up a little bit because it's tilting this way right now. Right? We want to bring that up. And then for our left to right, we'll need to just loosen this, get it square, and then tighten it all back up. And that should correct our left to right. So we'll get started here in just a minute. Okay, so I'm getting ready to cut this spanner wrench, Mark II. I did two things on it. I gave it a longer handle, and then I also gave it I rounded out the corner where the pin or the tooth comes out, because I noticed that I had a shear stress there, and eventually it was just going to want to tear that pin end off the spanner. So I went ahead and changed that around as well. So getting ready to do the cut. Might get kind of loud. I'm going to turn the fan on, a couple other things to help keep the room clear here. But one thing that I did do, and this will tell me if I have my offsets right in PlasmaCam, is if you have a long straight edge, or if you got anything straight, and you put it up against the edge of the metal in the drawing, when you go to convert it to a cut path, PlasmaCam will prompt you to convert using that edge so that you don't have to make that cut. So so basically what I'm saying is this edge here, right, this is X0, is not gonna, I don't have to make that cut. So it's just gonna cut the outside portion of it. So let's see how it works. I've got everything ready to go. I've got the Hyptherms at 45 amps. I believe, let me take a look here real quick. We've got our machine settings for 3/8 inch. We are cutting at 0.06 height. We're auto sensing for the height there. We're cutting 28 inches a minute and 0.9 seconds for time to pierce. So for those of you who are interested in that kind of thing, I'll probably put it up on the screen too. But let's go ahead. I'm going to press the start button and take us off. Wish me luck. Oh wait, let me get the fan going first. Alright, let's see if we can duck some of the smoke out of here as we do this. No cut paths were selected. Where cut paths first? So apparently I had the wrong thing selected. Okay, here we go. So one thing that I'm noticing already is that when the torch was off camber, the sparks would come out, it would shoot out more from one side than the other. I would see a lot more sparks coming out versus shooting down. So I think we've made a big improvement here. Once this cools off, we'll take a look at the edge and the cut quality, and I'll bring you back. Okay, so we've got spanner wrench version 1 and version 2, which I might add is still pretty warm. Okay, so what I'm going to do, let's take, what I want to try and find is the, let me see if I can show this on the screen first. Okay, when we're looking at the cut, I'm looking straight down this thing, right? I'm looking at the bevel I'm seeing here. Now this one was cut on both sides, the other one won't be, so we'll do an apples to apples comparison. I'm going to check this side right here and see how it did. I'll also check the inside here, because I actually, when I'm looking at it straight down, is when I see it the most. So we'll check both and we'll see. All right, so we'll start with our first edge here. That's flat. That's flat. Okay. I don't know if I'll be able to show you guys this, but I've got a good line up there, and what I am seeing is about 2 degrees. You guys see that okay? There you go. So I'm seeing about 2 degrees. And that's this edge right here. On the inside arc here, it's significantly more. Remember I talked about it being different based on the direction I was headed too. So now I'm looking at almost 5 degrees, right? So that's what was just throwing it off a good amount. So the difference being, right, when I was cutting in the X direction, we were off just a little bit, right? But when I was doing a combination or cutting in the Y direction, because I had a cant front to back and a cant side to side, it wasn't too bad. You'd get one or the other, but then on these arcs, I was getting both. And so the arcs, anytime I was doing a circle or any type of arc like that, you could really see it. So they compounded, and I got a much worse situation. So, all right, this is still a little warm, but that's why I got my gloves on. Let's see, so now on this straight edge where we were, actually, you know what? I'm at 90 degrees. I've got no discernible, maybe I'm half a degree. I don't know if you guys can see it or not. Maybe half a degree. So let's check that. Let's check the arc now and see what it looks like in the arc radius. And sure enough, same. So we've corrected the issue. I'm within a half a degree on that. So as long as I've got the height set properly on the cutting, we're good to go. Okay. First things first. Definitely, I'm going to say this over and over again. Thank you so much, Martin, our Texas gun guy. When I got this lathe, it didn't have a spanner wrench, and he has a very similar Colchester lathe. And so he took photographs with measurements to give me an idea of what the spanner wrench looked like. And so the first thing I did was I drew that up, and you should have seen the drawing by now. And I did a quick test cut, right, 14 gauge, but I did a test cut of my original design here to make sure that the actuating portions of it were going to work. And so I could come in, lock in, right, and then I could look along the edge, make sure that everything was engaging where I would expect it to engage, right? So it's all there, it's working. I've got a good part there. And I was pretty excited. It's like, all right, excellent, there we go. There's the first step. Of course, I sent a picture to Martin, and he kindly reminded me that this might not be thick enough. Of course not. But anyways, it was kind of nice. So then, the second phase of the operation, let's make one out of a thicker material. So this is 3/8 plate. Right? I happen to have a bunch of 3/8 here. I do a lot of cutting of 3/8 plate. And so I went ahead, cut it, tried it out, and again, looking good. I'm happy with how everything engages. But man, that little handle here, it just isn't much of a handle, right? You don't get a whole lot of, you just don't get a whole lot of getting a lot of leverage there. Although that I'm shaking that whole lathe like that. So maybe I'm getting more leverage than I thought I was. Which brings me to the cutting we did today. This guy, right? This one. This is my first test. I haven't even knocked the dross off it yet. You can still see a little bit of dross on there. was my first test, and it's gonna be all right. It engages well. It engages how I would expect it to engage. You know, where, yeah, I think this is gonna be okay. So I'm gonna go ahead and get this thing cleaned up, and then might give it one good test here. I don't know the last time this thing was actually off the spindle, so I might need to hit it with some penetrating oil first. But this is today's project: is get this going so that I can actually pull this chuck off and give it a good service, because it's actually very difficult to move in and out. It's got a lot of gunk in there, and I noticed some run out as well, so I'm not certain if everything was put together properly. So I'm going to work on that shortly. But for right now, this was today's project, is get this part of it done. So thanks for watching. The other day, I was cutting some stuff, and my daughter was here, and sparks were going everywhere, and she really got on me about not having that guard on there. So I broke down and put it on there, and it's like, I'm trying to set an example for a 7-year-old. And it really makes you think about the things that you do versus the things that you say. Always on her about being safe. I wear my, you can't see it in here, sorry, but I'm always wearing my PPE, but then I wouldn't have a guard on. And it keeps catching me, because I keep going to do things that I can't do because it's in the way, right? But frankly, maybe it's time I do things a little different. Alright, so we got all the sharp edges off here. I might take a file or some sandpaper or something, just smooth it out a little bit more. Frankly, it's a spanner, right? It doesn't have to be anything crazy. Now, one thing I didn't do, when I decided I was going to extend the handle, I didn't measure it. I literally just drew a straight line, stretched it out, and attached it. So now our overall dimension is 26 and an 8. 26 and an 8, yeah. The handle, before it goes into the arc, is 18 and a half, overall 19 on the handle, 19 inches. The original drawing, the whole dimension was 13 inches. So, yeah, here we have it. And one fancy spanner wrench. If you need a spanner wrench like this, let me know. I'll be glad to help. Thanks, guys. Okay, so all kinds of neat things happened on this particular project. Try and record my screen and audio doesn't come through, all kinds of good things, but it still didn't stop me. I still got through. And so little voiceover technology, and so you saw how I did the drawing, you saw how I cut it, and hopefully this thing's going to work out just fine. I don't know if I'm going to need to harden it or not. It's just, hot rolled 3/8 plate, so I might need to have this hardened and tempered so that I get a little better better wear qualities out of this. But the nice part about this is I have the drawing now. Anytime I need a new one of these, click, make a new one. So that part of it is very, very helpful. Yeah. The last note to bring up, and it's kind of a continuation from last week. I will more likely than not be having back surgery here, and it might be a month out at this point. I don't know yet. We're still trying to work this out between the VA and my medical insurance and the civilian doctor that I want to do the work. So we're still trying to work out the details. No complaints at this point, but just have some paperwork to get through. That being said, that's probably going to sideline me for a little bit. During that time, I still want to produce some videos. I don't know how often I'll be able to do that, and the content of which will likely not be as physically demanding. I might do more of the CNC work that I was talking about, more of the drawings and the design side of things. I talked about doing more on the PlasmaCam and teaching people how to use the PlasmaCam. So there are still things that I'd like to contribute, and I feel like I can continue to contribute during that time frame, but just be aware. I know some people really just want to see the machining side of things or the cutting and the welding side of it, and physically I just won't be up to it. I don't feel like any of you pressure me to do that. In fact, you guys are great. If anything, it's quite the opposite. This is a very supportive community, and I'm proud of all of each and every one of us that are a part of it. But I've received so much from this community, I want to be able to give something back too, and so that's why I make these videos. Not everybody has access to the tooling that I have. I don't have access to some of the tooling that other people have. So it's a give and take. That's why we do this. So I just want to say thank you, and I'll keep everyone posted as we go. If you enjoyed this video, please give me a thumbs up, like it, share it with your friends. Thank you very much for watching, for all my new subscribers, and especially for all those guys who've stuck with me from the beginning. Thank you very much. This is Tom from Inspiration Metalworks, signing out. Happy Sunday. I'm still not in the screen. Oh, love it. Someday, I'll be able to afford a dedicated cameraman. For now, it's just me and one camera.